Welcome to VPC networks and load balancing for Google Cloud. In this course, we're going to learn about the design and topology of VPC networks, as well as the different types of load balancers that they provide for us. We'll also cover how to set up health checks, which can be used in managed instance groups as well as load balancers. Let's start by introducing the Google VPC and look at its topology. So what is a VPC, or a virtual private cloud network? You can think of a VPC as your own private virtual network that's hosted inside Google's public cloud. So you're getting the best of both worlds, a scalable, available, and isolated network which is private only to you, that still comes with routing and firewalls like you're used to. But you have the elasticity and availability benefits of the cloud. VPC networks are required for anything that requires IP networking in your Google Cloud project, such as virtual machine instances. The really neat thing about Google VPC networks is that the VPC network itself is a global resource, and the subnets that we create and configure inside the VPC are regional resources. So subnets span all of the zones that make up a region, meaning that we get the resiliency of our network spanning over multiple zones, plus the simplicity of having our VMs in different zones without having to complicate our network design. In a moment, we'll show this in a topology view so you can see what I mean. VPC subnets can host internal IP addresses for our private services and applications, as well as external IPs for our internet-facing applications. There's no need to complicate our network designs with separate public and private subnets. Google Cloud VPC subnets can take care of both, and if you want a resource to be private, just don't give it an external IP address. So another way to introduce ourselves to the VPC is to look at a topology view, and this helps to highlight where a virtual network in Google Cloud differs from other cloud vendors. As we already know, resources in Google Cloud exist inside projects, and that includes VPC networks. So a VPC network belongs to a Google Cloud project, and in fact, many VPC networks can exist inside a project. But a VPC network is, by default, its own communication boundary. As we previously said, a VPC network is, however, a global resource. It spans every available region in Google Cloud, meaning that the same network can span the US, EMEA, and APAC all at the same time. We can now see more clearly in this topology view that within a VPC network we have subnets. Subnets are regional objects that provide specific private IP address ranges inside your VPC. Subnets span all of the available zones within a region, and again, this means that you can create resilient yet simple network topologies. Each subnet can be assigned a network range from the RFC 1918 specification on private IP addressing, and in this way all subnets are private unless we choose to add an external IP address to a specific resource like a virtual machine. Now, we mentioned earlier that it's very easy to keep your virtual machines private by not assigning them a public IP address. But what if you need to connect to the internet, for software updates for example? Enter Cloud NAT, or Network Address Translation Service. This lets resources you specify create outbound connections to the internet or to other VPC networks, on-premises networks, or other cloud provider networks. Cloud NAT supports address translation for established inbound response packets, which means it does not allow unsolicited inbound connections. To enable Cloud NAT, we just need to create a Google Cloud router and then configure Cloud NAT to use the cloud router. So again, an example of this in the real world would be to have a VM which has a private IP address but no external IP address. By default, it wouldn't have a way of making outbound connections when trying to update or install a package, for example. But with Cloud NAT configured, we can keep the VM internal facing with no external IP address and allow a controlled connection out to the internet, but nothing can connect into the VM from the internet. While we're working with private VMs that need internet access, what about if we just need to access other Google services or Google APIs? That's where Google Private Access comes in. Google Private Access helps make connections to Google's APIs privately. Private VMs are allowed to connect to the external IP addresses of Google APIs and services, keeping the connection within the Google network rather than traversing the public internet. Google Private Access can be enabled on a per subnet basis. An example for a real-world use case could be, say we have a Python application running on a VM that needs to output some files to a Google Cloud storage bucket. This VM does not have an external IP address, only a private internal IP address. With Google Private Access enabled on the subnet, where we've placed the VM, it can connect and communicate with the public IP address of the Google API, in this case, the Google Cloud Storage API, keeping the traffic within the Google Cloud network and not sending it over the public internet.